Hi everyone and welcome back. Today, I'm going to show you how to run Deepseek and other uncensored AI models locally on your own machine, whether you're on Windows, Mac, or Linux. Now, here's what we're going to cover. We'll install Deepseek and another uncensored model on your computer using LM Studio, which is a very powerful tool suitable for both beginners and advanced users. Then I'm going to walk you through setting up a remote server with Ollama and OpenWebUI on Debian 12. This includes Docker setup, PCI Passthrough for GPU acceleration, NVIDIA drivers, Cuda, and the Docker's NVIDIA Toolkit. Now, for those wanting to run this directly on their Linux distro without any kind of containers, I'm going to show you how to install Ollama and run the models natively. Finally, I'm going to show some alternatives, such as running these models on your favorite NAS. You can watch the full video or jump straight to the section that you need. The timestamps will be in the description. Now, there's a lot to cover, so let's get started. Now, let's start by running Deepseek locally. To do this, we're going to use LM Studio, which is a very powerful tool, yet easy to use for running Gen AI models on your local machine. Whether you're a beginner or advanced, it doesn't matter. So head over to lmstudio.ai and download the version for your OS. The installation is super simple. Just double-click the installer and follow the prompts. Now, if you're using LM Studio version 0.39 like myself, you'll be prompted to download the Deepseek model right away. Just hit download. And if you didn't get that option, don't worry, because I'm going to show you in a minute how you can actually load models manually. Now, once the download is done, just click Start and then Load Model. This loads the model into your GPU VRAM for, of course, faster performance. And if you want to confirm if it's using your GPU, all you got to do, at least in Windows, is just hit Control, Shift, and Escape, and then go to Performance GPU. Just make sure that you're selecting the NVIDIA, because you might have more than one GPU in there, like your iGPU, for example. Now, since this is a 7 billion parameter model, it takes around 7 gigabytes of VRAM. And that's it. You're now ready to run AI models locally and you can start experimenting. So just go ahead and ask something. Now, all AI models come with some level of bias shaped by their training data and the policies of their creators. So if you ask something controversial, the response will likely reflect the vendor stance, since that's how at least these models are trained. But what if you're a security researcher? Conducting some threat analysis, for example, or working with some sensitive company data. A censor model may block critical insights or just give very patronizing high-level, surface-level responses. This is where uncensored private models become invaluable. They allow for full control, complete privacy, and unrestricted exploration. And they can achieve all of this without sending sensitive queries to a public model. So, in order to start using these uncensored models in LM Studio, let's eject the current model. Then you can use the search bar to find an uncensored model. Now, one of my favorite ones is the Dolphin Mistral. However, this has 12 billion parameters and requires roughly around 10 gigabytes of VRAM. Doing this AI stuff requires a beefy GPU. If you don't have a GPU, it will default to your CPU, so things will be considerably slower. Now, before downloading, you can review the model's README file, and this contains key aspects like quantization levels, parameter sizes. It's really handy, and I have to say, it's a feature that I really appreciate. Now, click download and wait for it to complete. Once downloaded, you can load the model and LM Studio will display its status. And again, you can verify the GPU usage by just hitting Control, Shift, and Escape and checking the performance under the GPU tab. The 12 billion Dolphin Mistral model uses about 8 gigabytes of RAM, and there's another 1 or 2 gigabytes reserved for the OS. Now, when you ask an unconventional question, the model might still hesitate a little bit, but it will provide an answer, rather than just outright refusing it or just start blabbing away. And also in LM Studio, you're not limited to the chat interfaces. You can also use the Developer Studio, and this will allow you to do things such as launch an API server directly within LM Studio. Just click on the Developer tab and launch the LM Studio server. And you can also send API requests to the model for automation, scripting, or integration with other tools. With an uncensored local model, you now have complete control over your AI, making it a powerful addition to your workflow. And again, I keep saying this, but it's all private. And now comes the fun part. Now, so far, we installed these models locally, but I know that a lot of you, like myself, will not want to be running this stuff on your main computer, as this is really resource intensive. Also, you might want other machines or clients accessing these models within your network. So next, I'm going to show you how to install this in Linux. Now, I'm going to be running this in a VM, but this will also work on a native installation directly on the bare metal. Now, regardless of the method you choose to install, we will have to first install and configure a couple of prerequisites. Now, I'm using this VM in Proxmox, but you can use whatever you want. Now, first you need to create a VM. If you don't know how to do this, just please go ahead and check my Proxmox video around this timestamp right here, and it tells you how to create a VM in Debian. If you don't want to watch this entire video or even just a section, the important thing here is that since the GPU that I'm using is a GTX 1080, this type of GPU uses what I believe is the Pascal architecture, if I'm not mistaken. So I need to choose CBIOS and Q35 machine so that I can use the PCI Express. Now, due to the architecture of my GPU, UEFI will fail. Maybe it will work for you, but at least for me, those are my settings, and I've tried this time and time again, and it didn't work. Now, once you have the VM created, make sure that you add PCI Passthrough, and you tick all the functions along with PCI Express, because you want the entire I/O group for your GPU, if that makes sense. Okay, with the VM created, we are now ready to start the VM. And by the way, so that you just know, this is a completely freshly installed Debian 12 installation. It's as bare as a newborn. Now, let's get everything in place for GPU Passthrough and containerized AI workloads. So in order to do this, follow these steps carefully because order matters. So first, install sudo and add your user to the sudo user group. Now, I'll put these commands in a document, which I will publish on Medium or on my website, if I ever have the time to finish writing that website. Now, after adding yourself to the sudo group, log out and SSH back into your distro. And as always, I'm using MOBA Extern because it's my go-to SSH client. Now, I always install these packages that you see on screen. You might not need CIFS for this setup, but everything else is crucial. Especially the Linux headers, since they're required for the driver's installation. Now run this command to upgrade and update your system. Now, I like to keep things simple, so I use a Docker convenience script to install Docker. Just run this command, or again, grab it from the document that I will have in the description, and this will install Docker. Once Docker is installed, add your user to the Docker group for a seamless access. So if you like managing containers via the terminal, that's perfectly fine as well, but I personally don't have the time for that, so I install Portainer for an easy web UI interface. And it's also really simple to do. All we gotta do is just create a Docker volume for Portainer, and then the next thing is basically just running the Docker command to install it. So once this is done, open a browser and navigate to https://ip:9443. You just do a very quick registration, and Portainer is ready to manage your containers. Now, next we're going to be installing the NVIDIA drivers. And again, this is where the order really matters, okay? Because if we don't follow this particular order, I don't know what can happen, but I know nothing good might come out of it. So go to the NVIDIA website, and the link is in my blog. Select the right options for your setup, which is probably what you see on screen if you've been following along. Now, copy and paste the commands one by one into your terminal. And after that, install the NVIDIA driver. But be careful with this step, because your GPU architecture matters. I'm using an old GTX 1080, which, like I said, I believe it's the Pascal architecture. I didn't Google it up now, but from memory at least. So I need the legacy kernel flavor, not the open drivers. If you're using a different GPU, read the documentation and install the correct driver. And then once everything is installed, just reboot the system to apply the changes. Now, after rebooting, it's time for the first milestone, which is checking if your GPU is properly detected. In order to do this, just type NVIDIA SMI and fingers crossed. If you see the NVIDIA status screen, you're on the path of righteousness. So, if not, something went wrong. Either the installation was incorrect or your GPU just simply can't be passed through. Since everything is working, I usually take a snapshot of my VM at this stage. If you're using Proxmox, follow along. And if not, you can skip this step. But if things break later, you're gonna wish you had that snapshot. Now, let's ensure that Docker can actually use the GPU, because that's why we've been bothering with all this stuff, right? So for this, we need the NVIDIA Container Toolkit. Otherwise, Docker is just going to default to the CPU, making all of this previous work worthless. So go to the NVIDIA Container Toolkit page. The link is in the blog. Follow steps 1, 2, and 3. You can ignore the experimental packages. Then to restart Docker, you can just type sudo sudo systemctl restart Docker. Don't forget sudo if you're not logged in as root, but if you've been following along, you won't be. Now, for the second moment of truth, verify that the Docker containers can actually access the GPU. Run this command, pause the video if you need to, or go check in my blog, and Docker will download the image and run it immediately. Now, if you see this message here that you're seeing on screen, beautiful. Now use Portainer to clean up the test image. If you're like me, take another snapshot because at this point, your GPU is fully SEP and ready to rock and roll. Now, this was hands down the most complicated part of the setup. And look, I'm not here to give you a pep talk, but if it didn't work the first time, don't get discouraged. As a matter of fact, it's very likely that it's not gonna work first time, okay? I've spent years messing around with this kind of stuff, and trust me, trial and error is part of the process. Just persevere and you'll get there. Also, if you need help, drop a comment, and if I see it, I'll do my very best to answer. And of course, if you found this content useful so far, hit that like button and subscribe because it really helps me keep making videos like this. Anyway, back to the AI, okay? Now that we have the groundwork all done and laid out, let's go and carry on with our AI. So in order to do this, we're going to install Ollama, which will act as the engine to run these models. And why Ollama? Well, because it provides a powerful local API, making integration like really easy. It works seamlessly with OpenWebUI and gives you a very nice and clean web chat interface, kind of like the ChatGPT one that you've seen. Actually, I think they rip off the entire design, and everyone else is ripping off their entire design. Now, setting up Ollama is very straightforward. Just run the Docker command that you see on screen. Now, I won't go deep into what every flag does, but actually I am going a little bit deep just to explain to you and you don't think I'm just walking around with your system here. But if you're new to Docker, rest assured that these commands are simple and intuitive. I mean, Docker is very, very easy to get on with and to get started. So the -d, for example, just stands for detached mode, and it runs in the background, keeping the container alive even after the terminal session ends. So if you skip -d, the logs will be displayed directly in your terminal. The GPUs all, or -GPUs all, they give you the container access to all your available GPUs. And -v just basically creates a volume for the container. So it creates a Docker volume that allows you to persist model data, so it's not lost when updating or recreating the container. The -p just basically maps a port on your host to the container, so you can access Ollama externally. -name Ollama is just the name of the container, and Ollama/Ollama, well, this is the Docker image that we're going to be pulling and running. So in case you're not familiar with Docker, there's nothing shady happening here or anything like that, just standard setup. Now, once the command completes, you can check if the container is running. So open Portainer, go to containers, and this is why Portainer is so useful, and check the status. Of course, you can just run Docker PS in the terminal as well if you chose not to install Portainer. So now that Ollama is finally running, we need to download and run a model from inside the container. So how do we do this? Well, we go to the Ollama model library online and we can search for Deepseek. And it's currently the #1 model because it's the most talked about model at the moment, the NVIDIA stock killer as I call it. Choose the version that fits your system. And since my GPU has 8 GB of VRAM, I'll go with Deepseek 8 billion. Now, in order to run the model in the container, you just need to execute this command in your terminal. Docker exec -it Ollama, and then Ollama run and the model name. Docker exec -it just runs a command inside the Ollama container. Ollama, of course, is the container's name, and Ollama run, well, that's the binary and the running command that we have to basically pass in. Now, as you can see, it loaded the model into the VRAM and it's finally running. So go ahead and ask away. You can ask it anything. You got your local AI running in your computer. Now, there's a lot that you can do with Ollama beyond just chatting. So you can use its API to integrate AI into custom applications. And you can replace expensive cloud-based coding assistants, for example, by developing or by running, I wouldn't say developing, but by running a local LLM. If you're a developer with a home lab, stop paying for cloud-based AI and just run it. Just do it yourself is my motto. I actually have a video about that, so feel free to check it out. Now, I prefer graphical user interfaces over terminal commands, but that's just me. Especially if I want my friends or family or other clients, client devices to access these AI models. That's where OpenWebUI comes in. And to install OpenWebUI in Docker, just search for OpenWebUI on Google or whatever, but anyway, it's going to end up redirecting you to their GitHub page, so you're going to end up on their repository. Now, scroll down, copy the Docker command, and since we want GPU support, make sure that you use the right version of the command. Okay, then we need to paste this command into your terminal and hit enter. After that, we can just open Portainer, go to containers, and just basically click on the logs, and we can basically tail the log and see what's happening in real time inside the container. So I believe that, I think at least that this uses Nginx. So wait for the server to be ready, and once it is, you can refresh the page to see if the container is ready. And if it's not, just refresh the page again, because sometimes it doesn't do it straight away. Now, open the browser and navigate to http:// your IP:3000, because that's the port we mapped it. Oh, and one more thing, make sure that it's HTTP, not HTTPS, okay? Enter your credentials or register your credentials and you are in. Now, at the top, you should see the AI model listed, which means OpenWebUI is successfully connected to the Ollama container. And go ahead, you can ask whatever you want. Now, to verify in Linux if you are actually using your GPU, you can run the command watch-n1 NVIDIA SMI. I believe this will update every second, showing you the GPU memory usage and the processing load. If everything is set up correctly, you should see your NVIDIA card handling the AI model instead of your CPU. I think you would notice as well if it would be using your CPU instead of your GPU, because things would be a little bit slow. Now, at this point, your AI stack is fully operational. You've got Ollama running in Docker, you have Deepseek installed and ready, and you have a web interface, which is OpenWebUI, for you to interact with it. But the best part is, on top of all of this, we have a successfully passthrough GPU supporting all of this inference. Now, again, we face the same constraints that we did when using LM Studio earlier. If we ask the model controversial things, it will give you vague answers or try to dissuade us from keep asking these questions. So we can just try and run an uncensored model instead from the Ollama library, just like we did earlier with LM Studio. So just browse back to the Ollama library and search for Dolphin Mistral. Then you can copy the name of the model and run the same command we ran earlier. This time, replace the name of the model. Then just go back to OpenWebUI, refresh the page, select the Dolphin model that we just downloaded, and ask away whatever you want. I really like running these things in Docker, but I know that some of you guys might prefer to run this natively in the OS. So if this applies to you, this is what you have to do. Okay, so first we need to stop these containers, the ones that we just installed. That's Ollama and OpenWebUI. Now, next you need to go to the Ollama website, and these guys provide a convenience script if I'm not mistaken. So just click on the Linux operating system, and right under there, you will see that there's a convenience script, and all you got to do is just copy and paste that into your terminal window, and hit enter. Now, here's the thing though, if you actually do Docker PS and you type Docker PS in the terminal, you don't have any models. because the models we just downloaded earlier are in the containers. So you have to download them again. And the process is the same basically, only this time we execute the Ollama binary directly. That is, without the additional Docker command. Next, we will install OpenWebUI natively as well. Now, if you've been following along and have a clean installation of Debian, chances are that you do not have Python installed. In order to install Python, the fastest way I know is by using the package management software. So just type sudo apt-install -ipython3 and python3 -pip, and that will install Python. Then if you run python3 ---- version, it should return something like you see on screen, which is basically the version of Python. Now, just Python 3 isn't enough though. If you try to run pip install OpenWebUI, like indicated in the documentation, you will get a message saying that this environment is externally managed. And this means that we need to create a Python environment. Now, this is actually the best way to work with Python, I would say, because it avoids a lot of problems and version conflicts. Again, there's a million ways of installing or going about doing this, but I will show you the fastest way again. Let's just use the application management, software management tool or package management tool, whatever it's called. Just type sudo apt-install -y python3 -venv. Now, after the installation is complete, let's activate the new environment by running python3 -m venv myenv. And then we need to source this. So just type source myenv/bin/activate. And now we can run pip install OpenWebUI. It will download all the packages and install OpenWebUI for you guys. Then according to the documentation, just run OpenWebUI serve and rock and roll. Now, of course, once the startup is complete, simply type http:// your IP address, and then we use port 8080 because, well, we didn't specify a different port. Just complete the registration once again, create an account, and notice that your model is already selected at the top, which means that this interface is interacting properly with Ollama. And again, if you want to double check if you're using your GPU or not, just type the command watch -n1 NVIDIA SMI, and this will show you your CPU usage and load. And that's it! We've covered how to run AI models on Windows, on Docker, on Linux, set up GPU acceleration, installed all the libraries, and that's it. I mean, you can start experimenting with AI locally. I know, it's a bit of a tedious process, so I strongly recommend taking snapshots at key points, if you're using Proxmox, that is. Now, for completeness, I want to mention that many AI tools like Ollama and OpenWebUI are now available as prepackaged applications in various operating systems, namely in NAS software, for example. However, I'm not entirely sure if these packages include all of the necessary drivers, Cuda support, and optimizations for GPU inference, so, always worth checking before installing. One good example of these packaged applications is in TrueNAS, our very own TrueNAS. Not that I work for TrueNAS or anything, but you know what I mean, right? So if you're thinking about running AI models directly on the NAS, you can. However, you need to keep in mind one thing. You need a powerful machine. A weak NAS will struggle and will slow down your entire instance. So my NAS is a link station, and since it only has a GPU, or an iGPU, I wouldn't even dream of running AI inference on it. But maybe there's a little workaround, since Ollama is API based, you can install OpenWebUI on the NAS and have it connect to Ollama running on a dedicated VM, like the one we just did, for example. Whether it's in Docker or native, it doesn't matter. As long as it's installed on a very powerful machine with a good GPU, that's all you need. Just something for you guys to think about if you want your AI in your network without overloading your NAS, basically. I should probably stop here because this video turned out way longer than I expected, and the editing is going to take forever. So if you found this video useful, please give it a thumbs up and subscribe to the channel. If I get a lot of likes, I'll make more videos like this. It's a promise, okay? So thanks for watching, and I'll see you guys in the next one. Take care.